Okay, we are looking at the worksheet that was homework on Wednesday night. Starts out, looks like this at the top. And we were in the middle of going over G at the bottom of the back when the bell rang. So let me finish that off for you. G is like D, by the way. G and D are the only two on this worksheet that are like this, and that's the hardest type of problem you'll have. So if you know how to do this, then you know how to do everything on here. It says line L has the equation y equals 2x minus 16. Write the equation of the image of L after a dilation with a scale factor of 1/4 centered at -6, 6. The reason D and G are unlike the other ones is if you look at the other ones, most of them are centered at the origin, which makes it much easier. Okay, now we can't just, in this case, dilate the y-intercept. The reason why is when you dilate the y-intercept, and here's the center, it's going to move, and the center's not 0, 0, it's going to move this away from, that point is no longer going to be on the y-axis, which means it can't possibly be the y-intercept of our new line. So I do want to know where that point goes, that's why I'm using that point, but I'm going to have to also figure out another point. I'm going to have at least 2 points, because remember, any 2 points determine a unique line. It takes 2 points to determine a line. So I'm going to go ahead and plug in any value of x to find out what you would get for y, and that's another point that's also on this line. Somebody suggested that if we plug in 3 for x, we get -10 for y, so the point 3, -10 is also on that line. So start it off by finding 2 points that are on that line. So now, since the center here is at -6, 6, I'm going to shift these points so that everything would be centered at the origin. Okay, the way I do that is I subtract this center, just like it told me right here in the middle of example 2, these directions. I'm going to do this process to both of these points, and that's all I'm doing. So subtract -6. Minus a -6 is like +6, -6, and this gives me, it's not really a anything, so I'm just going to give it no name. This would be 6, -22, and this would be at 9, -16. Now what I can do at that point is I can multiply. That is basically where these points would be if I shifted everything so that my center of dilation was at the origin. So now I'm going to dilate by a scale factor of 1/4. So I'm going to multiply everything times 1/4. So this gives me 6/4, -22/4. This gives me 9/4, -16/4. We can reduce those. That's 3/2, and let's see, -11 halves, and 5, no, excuse me, I'm sorry, 9/4 can't reduce, 9/4 and -4. Let me erase that and rewrite it. Okay, so this is where it would be after the dilation if my center were at 0, 0. That's what I did by subtracting the center. I don't want to know where it's going to be after the dilation if the center is at 0, 0. I want to know where it's going to be after the dilation if the center is what it really is, which is -6, 6. So I undo what I did here. I shift it back to where it really belongs by, instead of adding 6 and subtracting 6, which is subtracting this point, subtract, add. -6 plus 6, -6 plus 6. I'm basically adding the point back in, plus -6 and plus +6. 3/2 plus 6, if you need to work it out and get a common denominator, go ahead and do that on your own. Maybe pause the video and do it. But 3/2 minus 6 is 3/2 minus 12/2, which is -9/2. -11/2 plus 6 is -11/2 plus 12/2, which is 1/2. 9/4 minus 6 is 9/4 minus 24/4. So that's, let's see, -15/4. I'll have to double check my math there. And -4 plus 6 is just 2. I'm going to double check myself. 24/4. Yeah, that's right. Okay. So this is where those 2 points end up. Not the most convenient points to work with, but that's what we've got. Now, we weren't asked for the 2 points, though. We were asked for the equation of the line. So we have to write the equation of a line, and so now all we're doing is writing the equation of a line given 2 points. And there are several ways to do that. The easiest way might be to use point slope form. And plug one of these in as my x1, y1, and one of them just in as x and y. Okay, so we have, let's see, that's my y. Okay, so 2 minus 1/2 equals m times x minus a negative 9/2, which is plus 9/2. What is our m? We already know what our m is because it's parallel, so that's actually 2. So I'm not sure what I'm doing here. I didn't really need that. I didn't really need to plug in that point. So I can take out that extra point I plugged in because I already know what m is. So taking out the just plain x, y I plugged in so that I've only plugged in 1 point. And then I'm going to get it in slope-intercept form so that I can see what the y-intercept is. So this is y minus 1/2 equals 2x plus 9. Add 1/2 to both sides, and we get y equals 2x plus 9.5. Or you could say that's 19/2. And that's your answer.